I asked some plant breeders some fun and interesting questions, and here's what they came up with.
Name an innovation in plant breeding that has affected you the most. I would say two areas. GMO technology has impacted my plant breeding career throughout my entire career. Second area that I would say is the transition of molecular DNA fingerprinting and how we've leveraged that at virtually every step of the plant breeding process, from population selection and every stage of advancement all the way to commercialization.
The molecular markers, I use molecular markers for much of my research. They allow us to answer many scientific questions, and they continue to deliver knowledge and discovery to our field.
Genomic prediction has had a huge impact on change in plant breeding.
The remote sensing, just the number of data points you can collect is astronomical.
Just the increased focus on data science for analyzing large data sets. We've been able to collect more and more genotypic, phenotypic data, and gaining insights into those huge data sets using different data science tools and techniques has been very valuable.
Fusion of machine learning in plant breeding and crop production.
Genome sequencing. We know so much more about all these different species and how crops and models respond differently to stress that I think that has been a real technical innovation.
Despite being a techie and loving all of the gadgets like drones and object image recognition, I think the most impactful technology to breeding has been the large data sets of genomic and phenomic information and being able to leverage genomic prediction algorithms to make those early selections before even getting to the field.
I get the most excited about the new generation of plant breeders who will continue the campaigns against hunger. I see awesome talent coming forward.
I think the phenomics will enable us to capture and dissect genetic variation at higher resolutions and make genetic gain progress while minimizing G by E. I think that's going to be very exciting.
With the technological advances we've seen in our field in the last 5 years, I'm most excited how that's going to drive genetic gain in the future in plant breeding of many crops.
Technology that enables the creation of genetic variation that contributes to genetic gain, even in species that have a very narrow genetic base.
As a part of the new generation of plant breeders myself, we face an ever-increasing set of new challenges and problems ranging from climate change, population growth, and genetic vulnerability. I'm really excited to see how we can bring in new ideas and overcome these challenges together.
What is the next paradigm shift in plant breeding? And I would say that's embedding a highly multiplexed genome editing approach into the breeding program model.
When I think of the next paradigm shift in plant breeding, the two things that I think of are gene editing technology and autonomous robots. Both of those things are likely to have far-reaching impacts on how plant breeding is done and how it's ultimately delivered to consumers and customers.
The next paradigm shift in plant breeding, I think it could well be systems thinking. Bringing systems thinking into the decisions that we make allows us to work through the consequences of plant breeding sitting within biological systems, ecological systems, economic systems, social systems. Those are all complex and messy and difficult to work through. So having that systems thinking capability will help us do a better job of anticipating or reacting to the consequences of decisions that we make.
The next paradigm shift will be that plant breeding reduces the carbon footprint of agriculture.
Definitely artificial intelligence.
I hope the next 100 years in plant breeding will bring a much more solid understanding of genotype by environmental interactions.
We're going to definitely know more about the genetic diversity present in our particular crop of interest, but what's going to be key is how to determine best practices to harness that new knowledge that we've gained.
Plant breeding can have a very big impact on the mitigation of climate change in agriculture.
The world has changed so much in the last 100 years, it's hard to envision what might happen in another century. Maybe with a combination of technology and knowledge, for some species, we're moving towards designer crops for niche environments or uses where the desired combinations of stress tolerance, yield, consumer traits can be ordered and packaged in assembly line fashion.
I think we'll be seeing double, triple, quadruple genetic gain.
I think the environment changes are going to bring more diseases and insect pressures that are going to have to be overcome with a multifaceted approach to technology.
We'll be expected to develop plants that can do so much more than they do right now. We'll have a lot of challenges that are stacked against plants and us breeders, but we'll also have plenty of tools to alleviate those challenges.
I think reaching new ways of scaling up gene interactions and interlocus interactions to breeding program level will I think lead us to a next level of understanding how to implement new breeding strategies and generate novel genetic variation, as well as understanding more about the regulatory processes that the plants have for undergoing meiosis, and so being able to control this process in a more guided way will also bring very exciting changes to plant breeding.
The NAPB Conference will be in person at Iowa State University from August 8 to 11. Past, present, and future of plant breeding is the theme as we take time to celebrate the past, discuss the challenges of today, and explore future prospects in plant breeding through multidisciplinary efforts. There will be tours of the PI station, what I refer to as the seed bank, Corteva, Bayer, Kemin, Power Pollen, and of course, Iowa State's agronomy farm. This will be the best conference you'll attend in the past 3 years. Come reconnect with friends and colleagues and make some new memories. I hope to see you there.